Hi, I'm Gabriella Milgram.
And I'm Anna Kate Wheeler, and this is our project on Instagram analysis. So first of all, we used Instaloader in order to collect and analyze our data. Instaloader is Instagram's only official API, and it's the way that you're able to scrape data from Instagram legally. They have very strict privacy policies, and so using Instaloader is the only way we were able to follow their guidelines. So that is how we collected and analyzed our data.
So then to be able to conduct a thorough analysis on the user, we wanted to be able to compare the user's data to other profiles because that's the way that marketing normally works. So we found the top business users on Instagram and made them into a TXT file. As you can see here, businesses.txt, and it has a very long list of the top business users of Instagram.
So we took all of these usernames and we went through all of them. And so we opened the business TXT file and then we stripped out any white space and the ats at the beginning of each username and then added them to a list. And then after we went through all of these, we were able to start collecting data using these different Instagram profiles. We were able to first use the profile instance in Instaloader to create profiles of each of these different businesses, as well as use the different, as you can see here, we went through each username in the list that we created from the original TXT file and created the profile using the instaloader.profile and then appended it to a new list that collected all the profiles. And then we did kind of the same thing, iterating through all of these profiles in order to collect all of the posts. So this is an example of some of the ways we collected our data using this list of usernames by passing it through instaloader methods.
And then to be able to append the data to the CSV file, we created the header. So you can see that has username, num total posts, num followers, and that's just all the data that we collected. Then we zipped the information to the CSV data, and then for each line appended the information.
Yeah, so if you don't know what zipping all the data together does, basically that is going to take like index 0 from each of these different labeled lists. So index 0 from username list, index 0 from num posts, index 0 from num followers, all the way through, and put them all together. And that allows you to append it correctly to the CSV file so that each user is connected to all of their data. So basically we just wrote all of that data back into a CSV file. And this is an example of this CSV file that we uploaded to GitHub. So it's presented in this kind of nice format, but you can see, so like for Nike, here's their username. This is the total number of posts they have. This is their number of followers. They have made 20 posts in the last 30 days. Their average posts per day rate is 0.666. And then total likes are here and it continues on like that. But this is just a little sample of some of the data we were able to collect and save to the CSV file.
Here we have the login information for a user. So we use Instaloader to create an instance of their profile. And then we request their credentials with a credentials class that we'll go over after this. And then we try to create the profile instance with the username and password that they provided. And if it doesn't work, then we raise an error. That would mean that they either entered an invalid password, invalid username, or that profile just doesn't exist.
So here's a little example of the credentials class that we made. It stores the username and password and then allows you to set and get the username and password just so that it's not being stored directly in the main where we're running the rest of our code just for a little bit of privacy purposes.
So to create our interface for the program, we use tkinter, which is run on Python, and it basically displays all the buttons and functionalities that we need for our program.
So as far as the logging in screen, we were able to take the code that we just made, doing some after we learned a little about tkinter, we were able to adjust that initial code and present it in this format where it pops up and it opens this box and it allows you to type in your username and password and even hides your password as you were typing it in. We just want to warn you that when we are running this, we ran it with a tester account that we created. So obviously the data isn't really accurate to what a business account would be. And we will kind of explain how that might have skewed the results, but we just for like our privacy purposes, we wanted to run it with this tester account that we created.
So once the profile is created, we wanted to collect and analyze data from the user's profile. So here you can see how we collected their profile, their follower and following data. We calculated the follower count, the specific follower users, and did the same thing for the followees. And then to find the users that don't follow the user back, we did followees minus followers. And then to do the percent that don't follow you back, we took the don't follow you back count and the followee count, then divided them by each other and multiplied times 100, and that would be the percentage. And then did vice versa for don't follow the people that you follow that, no, people that follow you that you do not follow back.
Yeah. So
Sorry.
basically this was just a little analysis on the followers and the followees for the user. This is something that requires you to be logged in order to do. You're not able to see somebody's followers and followees if they're not logged in. So this is only data that we're able to collect for the user themselves after they've entered their username and password. We can't collect it on all of the bigger businesses. So that's why we wanted to do some analysis on kind of like the people who don't follow you back and what percent of that total what percent of that is of your total follower count. So then we continue to kind of collect data on the user themselves. For example, the posting rate versus engagement rate. We collected the number of posts in the last 30 days and the number of posts per day in the last 30 days, which we just calculated by using the number of posts in the last 30 days divided by 30. Then we went through, and if the number of followers didn't equal 0, then the average daily engagement, if it equaled 0, the average daily engagement would be set to 0, because otherwise it would cause a division by 0 error. And that was just the easiest way to be able to present our data. And keep it clean and not have any sort of things like none when we went to graph it, stored in our data set. And same thing here, they needed to have the num posts in the last 30 days not be equal to 0 in order for this to calculate correctly. And basically we did a very similar thing, but this one is done by comments. So we look at the number of comments in the last 30 days, collect them and add them up into this variable that we have here. And we continued doing that kind of analysis throughout in order to collect all the different data that we wanted for the individual user.
So to be able to compare our users' data to other accounts, we read the businesses.csv file that we had created with all the business information and made everything into lists to make it easier for us to access the information later on.
So now we are going through, and this is a little bit of the code that we used when we were finally putting our program into the tkinter. So this get followers eventually turns into a button on tkinter, and basically it clears the previous text, and then it goes through and it takes the number of followers, which you've already calculated and stored, and says you have this many followers, and prints that to the screen. And then it prints out your followers if you have any at all. And then it saves them to a TXT file. This just allows the user to go back and look at their data later if they want. It will be saved into a TXT file on their device. And so this is just a little sample of that. And then here we have the interface. So if the user goes in, they click this get followers button, it will print you have 8 followers, your followers are, and then list the people who follow this account.
So here we have the get followees button, which you saw on the last screen is below the get followers button. And here it will display again on the sequencer the number of followees and who they are. And it will write the information to a followees.txt file. And here you can see how it will print this below the get followers function. So you get to see what you had clicked before and what you had clicked after. So it makes for a more comprehensive analysis.
So we did a similar thing here. We've taken the already stored data of the amount of people who don't follow you back and the percent that don't follow you back, and printed them to the screen, and then also printed who these users are. Once again, save those to a TXT file. This is the third button on our screen. After you've entered your data, you can click who doesn't follow you back, and it will print the number of people who don't follow you back, what percent that is of your total followers, and then the account specifically.
So here you get people that you don't follow back. So it's going to show kind of the opposite of what the previous button did, but you'll see the people that you do not follow, or I get the users that follow you that you do not follow.
Yeah.
You get the percentage of that, and you see the users that follow you that you do not follow back.
Yes, and it saves those to TXT as well in case you want them later.
Yeah, so in this case, there's 0 users that the account follows that it doesn't follow back, that don't follow them back. Like, no, it's 0 users that follow the account that the account doesn't follow back.
And so in this case, we've run into this exception where because there are 0, it doesn't print the list and it doesn't print these users are. So if you have 0 in any of these 4 categories, it won't print the list and it won't print this intro title to the list. So that is the 4th button. Next, we have the get user data analysis stats. So this is all the stuff we calculated before. We calculated the number of posts the user made in the last 30 days, the average number of posts they made per day. So that's their number of posts divided by 30, the number of likes that they had in the last 30 days by iterating through each of the posts on their profile and using date time analysis in order to determine if it's in the date range of the last 30 days. We also did the average daily engagement by likes in the last 30 days. And so that takes the amount of likes that you've received over the last 30 days divided by 30, because it's been 30 days, divided by your number of followers. So this is compared to the amount of followers that you have. This one does a similar thing, but instead of doing it by day, it does it per post. So it's the number of likes you have divided by the number of posts you have divided by your number of followers. Once again, calculating this rate based on the posts you have made in the last 30 days. And then here at the bottom, it does the same thing, but it's based on comments. So this is comments divided by your number of followers divided by the number of posts you've made in the last 30 days. So all of this data was previously calculated. This is just in the button actually presenting it onto the screen. And once again, this data does get saved to a CSV file so that the user is able to access it later if they would like to see it. This is a sample of how this data prints. Once again, goes onto the bottom of this list. This account that we created has posted 4 times in the last 30 days. That's an average of 0.13 times per day about. They've received 12 likes in the last 30 days. The average daily engagement rate is 5%. The average engagement rate by likes per post is 37.5%, because once again, that's compared to your number of followers. And they've received an average of 0.28125 comments per follower on each of their posts in the last 30 days. Okay, so basically this is the get posting rate versus engagement rate by likes. In order to do this, we went through and we cleaned the data. This filters out if there's any instances in our big CSV file of all of the business data. If any of them were none or had a division by 0, that caused it to be recorded in the file as none, we take them out of both lists. So we take them out of the average post per day list, as well as out of the average engagement rate per post by likes in the last 30 days list. So that accounts data will not be used in this to create this graph or this line of best fit. And after we go through this, we have created the base function for the line of best fit here. And then we go through here and we have the just basically making the plot, setting the figure size, the lens base for the line of best fit, solving for the different line of best fit aspects, and then scatter plotting all of the business data points in blue, and then we scatter plotted the user's individual data point in red. And then we've labeled the title x-axis and y-axis appropriately for this specific graph. Once again, this is still going through the graphing process. This is setting the X limits and the Y limits. It's based on whether the highest X or Y value is the individual users or the largest number in the business data set. So it just uses that in order to scale the graph so that they're not way too big or way too small. This down here formats the ticks on the display. This just rotates them 45 degrees to make it easier to read. And just does some other formatting things. This just places 2 decimal points, sets the Y's to percentages since we are calculating engagement rates in percentages. And this reveals the legend and actually displays the graph.
So here on the bottom, you'll see how it displayed the average number of posts per day in the last 30 days is 0.133. Your average engagement rate per post in the last 30 days is 37.5%. And then based on your average number of posts in the last 30 days, you're overperforming your expected engagement rate by 36.89%. So it'll basically like compare your data to the line of best fit and tell you whether you're underperforming or overperforming.
Yeah, so that is this button, this get posting rate versus engagement rate by likes graph on our interface. And then it produces this graph right here. Obviously, once again, as we explained before, this is skewed compared to what it would be for an actual business. Obviously, an account that has 12, 15 followers who are all friends with the individual user is more likely to actually post and engage and respond. And so this data point is obviously a major outlier, but you can see down here with all of the business data we've collected how clumped together it really is. And so this is the line of best fit. Really, if you zoom in, it's actually curved. It's just all down here, almost within this 1% range. It's hard to see since this data point is so far out, but this is just like allows you to compare your data to the other businesses that we collected data on. So the blue dots represent their data, the line of best fit, and the red is yours. So you can see how far above or below you are performing. Once again, this is scaled based on the largest amount. So if your amount was within here, it would give you a lot better view of the data. And if you were actually using this on a business account on Instagram, that would be really helpful and being able to view the data better.
So then you move on to the next button, get number of followers versus engagement rate by likes graph. It follows a similar logic to the previous graph. It just does it with a different metric. So in this case, it's number of followers and then by likes, and then the other one was posting rate by likes. And so it'll print out your number of followers. So in this case, 8, and then the average engagement rate per post, as well as how you're performing based on the line of best fit.
And once again, the graph compares you to the line of best fit. You can see all the data here. Once again, it's really curved. It's just zoomed in that smaller range. But you can see how far above or below you are performing compared to the average user who has your number of followers. So if you have 500,000 followers versus if you have 2 million followers, the amount of engagement that you're expected to have is different because it's harder to engage a larger percent of your audience if you have more and more followers. So you do want to compare yourself to other business accounts that are around your size. And this graph allows you to do that.
And then that graph will show how many followers you have as well as your engagement rate per post by comments, and then how you're performing based on the line of best fit.
Yeah, so here you can see that based on comments, this user is only overperforming by 0.2811%, but these percentages are also a lot smaller than the other ones because it's based off of comments per follower, and you're really not expected to get anywhere near a 1-to-1 ratio of comments per follower. So once again, still extremely skewed. Once again, this is not a business account for privacy reasons. But this is the clumping of all of the different data that we collected all down here at the bottom, and it compares, and like it said here, it's telling you how far above or below you are from the line of best fit. So that is our Instagram data analysis. We hope everyone enjoyed, and we hope that this can be really helpful for showing people how they are able to improve, whether that's by posting more or less, whether that's by trying to encourage higher engagement rates by likes or comments compared to their number of followers. So we're hoping that people are just able to use these graphs and analyses in order to improve the way that they're marketing themselves on Instagram, by comparing themselves to other businesses and how they're doing on Instagram.
Thank you for watching.